This is section 4.1, plotting points on a coordinate plane. This is called a Cartesian or a coordinate plane. You can see it has 4 quadrants, and I've numbered them quadrant 1, 2, 3, and 4. You can see that those quadrants actually take the shape of a C, so if you ever forget how they're numbered, just draw a C on your coordinate plane and you'll see how that goes. 1, 2, 3, and then 4. Because each point on the coordinate plane is named, you can assign names according to what the x value is and the y value, and we order that in parentheses with the x value first, followed by the y value. You can see by looking at this coordinate plane that the values are going to change with each quadrant. So in quadrant 1, both the x and y values are positive. In quadrant 2, the x value is negative, but the y value is positive. In quadrant 3, the x value is negative and the y value is negative. And in quadrant 4, it's positive and negative. So you should be able to identify each quadrant. Now we're going to look at naming coordinates in a coordinate plane. So we're going to look at different points. They've each been given a letter, and you have to give me the name of the coordinate. So if you look at these, we always list the x value first, then the y value. So for point A, you can see the x value is going to be -3. We move over 3 to the left of the origin, and then we go up 4. So its coordinates are -3, 4. In B, which is down in the 4th quadrant, it's a +2 for the x value, and then a -3. And then C is 0, 2. It's actually on the axis. That's how we get the 0, and then you go up 2 for the y value, so that's 2. You should be able to do the same thing with C, D, and E. Why don't you pause this and try that, C, D, and E. Given coordinates, you should also be able to plot the points on the coordinate plane. So you can look at any group of coordinates and draw them for me on the plane. So for example, take a look at point A is -4, 4, point B is 3, -2, and point Z is 0, -4. So why don't you take a second, pause this, and try to plot those points for me. If A is at -4, 4, we're going to go over 4 on the x-axis and up 4 on the y-axis, so this becomes point A. And then B is 3, 2, so we go over 3 and down 2. So this is point B. And then finally point C is 0, -4. That means it's on the axis, and then you come down 4, so that's point C. This should be very simple for you. This is just a review of something that you've done before. Now we're going to look at graphing a function with a specified domain. So this doesn't continue into infinity. These are just particular points that we're going to plot. So the function here is y equals 2x minus 1, and the domain we're going to use is -2, -1, 0, 1, and 2. To graph this, you're going to create an input-output table. Make sure your x values are on the left and your y values on the right. List those numbers that I gave you at the top, so -2, -1, 0, 1, and 2. And then using those numbers, substitute them into the function to calculate what y is. So take a second, pause this, and you should be able to calculate y for every one of those values. When you do that, this is what you should get. -5, -3, -1, 1, and 3. So we then take those values and plot them on the coordinate plane. So x is -2 and -5, so it's going to be way down here at the bottom. And then -1 and 3. And then 0 and -1. And then 1 and 1. And lastly 2 and 3. And you can see if this continued and we connected these, that this is definitely a line, right? The functions that we're working with are linear functions. That means the power of x is just to the one that is a line, right? I'd like you to try to graph this function, y equals -1/2 x plus 1, with this specified domain of -4, -2, 0, and 2. So the first step is create an input-output table, and then you're going to calculate the value for y for each value of x, and then you should be able to plot the points and identify the range. Now remember, domain and range. Domain is always the x values, the range is always the y values. So pause this, get a piece of loose leaf, and calculate the input-output table, the range, and then you should graph it. This is what you should get when you plug those values into the function, and this is what your graph should look like. So it's 4 points with a downward slope starting in the second quadrant. Now let's try something a little more complicated. The table that I have for you here is the attendance at a school carnival before and after the school added different game booths in 2002. So you can see the input, the X, the years before or since 2002 is in the top row, and the attendance Y in hundreds are in the bottom row. So we only have 4 values there, a very small domain and a small range. You should be able to look at this data and tell me if it's a function. So you're going to have to think back to the first and second chapter and think, what is the definition of a function? A function has only one output for every input. So see if this matches the definition of a function, and you'll see that indeed it does. So we're going to try to graph these points to see if we can see any trends and what happened when game booths were added in 2002. Again, why don't you pause this? You should be able to sketch this out quickly. It's just 4 points. This is the graph that I ended up. You can see that before they added game booths at year 0, that means to the left in the second quadrant, you can see there was a downward trend of attendance. But once you add the game booths at year 0, that attendance started to increase. So not only should you be able to calculate the value of the function and graph it, but you should also be able to describe the trends that you see, the same way we describe the trends that we saw in the milk orders in the different classes.